All right, good morning, scientists. It is another sunny day here. It's gonna be hot. You know why it's hot? Because the sun's out today. So that's what you're learning about today is stars like our sun. First of all, let me just clarify one thing. This week and all weeks going into the future, I won't be taking work late, so make sure you got it in on time, all right? So today I'm gonna be working on finishing up grading papers that you turned in last week. I'll get all that stuff graded. Hopefully by the end of the day, all those will be on Canvas and I'll upload those to Pinnacle and you'll be able to see them. So for today's work, your first job is there's a video on there about the Hertzsprung-Russell diagram. So Hertzsprung and Russell, they're two scientists who came up with a way to analyze stars by their brightness and their temperature. You might think like, really, that was a big deal? But it was. So they created a graph where they have all the dimmest stars at the bottom, all the brightest stars at the top, and all the hottest stars over on one side and the coolest stars on the other. So in the video, they kind of separate the stars. If you remember, there was that Hubble Deep Field view of galaxies that we were talking about in class before we left. They're going to take that same image in this video and they sort the stars out, and you're going to see some patterns develop. And the patterns that you'll see there, that's the Hertzsprung-Russell diagram. And that pattern reveals the life cycle of stars. So when you're looking at that, check those patterns out. There's also another link to a Hertzsprung-Russell diagram on today's work. You're going to sketch a little copy of that on the back of your other assignment. Speaking of your other assignment, is about the life cycle of stars. Now, as far as life cycle of stars go, couple things. Number one is the mass determines how much gravity something has. So let's say, remember we learned about what the Earth is made out of earlier? Well, if the Earth was made out of a lot heavier elements, then the Earth would have more gravity. In other words, you would weigh more. But the Earth, we know what it's made out of, but if we went to another planet that was made out of mostly iron, mostly denser material that was the same size as the Earth, you'd weigh more there. So stars, same thing. The more massive a star is, the more gravity it has. And the more gravity, if you remember, what powers stars? Fusion. So fusion powers a star. You got all this matter being crushed together. And when that matter is crushed together, that's what creates the nuclear fusion in the core of a star. So more mass, more gravity, more fusion. So an average star like our sun is about average size. Anything about the mass of our sun to about 1.5 times more is going to go through its life cycle where it'll eventually turn into a dwarf star. Again, there's a diagram. You're going to see all this, so you don't have to memorize it. It's on the diagram on today's module. If a star is bigger than the sun, 1.5 to 3 times the size of the sun, it's going to go through its life cycle much faster because it's got more gravity, making that fusion happen faster, and it's going to eventually swell up and become a red supergiant and explode in a supernova. So supernova is just a star exploding, and eventually there's enough gravity, it'll collapse back down to a neutron star. Now, a neutron star is a star where the entire mass of the star has been collapsed down, where all the protons and neutrons and electrons have all been crushed down, and they're all neutrons, and there's no space in between any of the atoms. Even there's no space left inside the atom either. So it's all very dense material. A teaspoon of a neutron star would weigh something like hundreds of thousands of tons. So it's a very dense material. So a very small object with lots and lots of gravity. So it's not really giving off any light, but it does give off radiation, and that's how we can detect, and that's how we know about it. Third type of star, if it's 3 times larger than the sun or bigger, then it goes through the same stages, goes even faster through its life cycle, becomes a red supergiant, goes supernova and explodes. But then when it collapses down, not only does it become a neutron star, it continues to collapse down and becomes a black hole. If you want to learn more about black holes, there's Brain Pop on that. You can learn about black holes. There's lots of other material about black holes you can search on your own. That's a little outside of the scope of 6th grade science, so we're going to skip that part for right now. So at the bottom of the module today, it says Life Cycle of Stars flow map. Take a look at that flow map, and you could either copy it down and do it on your own paper, or if you're able to print it out and take some notes on it, that diagram of the star, diagram of life cycle of stars, copy that onto that diagram. And on the flip side of that diagram, write some notes about the Hertzsprung-Russell diagram, the HR diagram that's in the video. In other words, how do stars go through their life cycle, and what are some patterns you may notice there. All right, so This week, I'm going to end up on Wednesday doing another question and answer live session from 12 to 12:30. So hopefully I'll see you then. I'll have the link on Wednesday's announcement so you know where to join the meeting. All right. I'll mention and remind you about that again tomorrow. And that's it. So looks like a nice windy day out here, and it'll be hot this afternoon. So since it's hot and be hot this afternoon, you might as well stay inside and do your work. All right, so get outside, get a little exercise in the morning while it's still cool out. Make sure you're getting all your work done on time, because I will not be grading it late. So I need to manage my workflow so I could actually get grades in. A lot of students are asking, hey, where are my grades? Why is this not posted? And it's like, well, I've got a lot of students. I'm kind of giving some extra time. So I'm trying to get everything graded all at once and import it all at once into Pinnacle. So I need to keep hard deadlines now. All right, so the first couple weeks, it's kind of learning curve. Now, make sure you get everything on time. All right, again, stay curious and email me, inbox me with any questions you got.